Before undertaking any servicing, you must remove any hand and arm jewellery. This includes watches, rings, and any item that may come in contact with a live circuit. In almost all cases, before maintenance is carried out on the equipment, it must be switched off and isolated by disconnecting the AC mains cables. Two exceptions to this rule apply, where a fault can only be diagnosed with the mains connected, for example if a CPU fan is suspected of being faulty, and grounding purposes, that is if the manufacturers require that the AC mains cables be attached. Ground yourself to prevent electrostatic discharge before touching any static sensitive devices. We shall during this lesson discover what electrostatic discharge is. Working on any electrical appliance requires strict procedure, not only for you but for other users, and we must be aware of the areas within the equipment that can cause electrical hazards. Even the most experienced engineer can receive an unpredictable electrical shock that could be fatal if no one else is there to help, so avoid working on electrical equipment alone. We must also consider component safety. One loose screw inside the case could be enough to destroy the computer if it falls into the wrong place, so keep a track of the screws, and if one is dropped, be sure to find it, no matter how difficult, even if it means disassembling everything. Be very careful not to short out components with a screwdriver. Even when switched off, some components will hold a charge for a significant period, and shorting them out can damage them. When disassembling, keep track of which screws go where. Many devices will use different screw types, and only the right ones will fit properly in the right places. Forcing screws in and or over-tightening them can strip screw threads and lead to screws falling out. Certain components such as hard drives and CD, DVD-ROM drives can be damaged by dropping them, or if they receive a knock, since they are manufactured with a very high precision engineering. Various drives are only designed to be operated in certain positions. Running some hard drives upside down can cause problems and corrupt data stored on them. Try to handle components by the edges rather than touching the electronics, even when wearing an anti-static wrist strap. When inserting components such as memory, avoid stressing the motherboard too greatly. If the motherboard is going to bend when you push the component in, then place something underneath it to prevent this. Static electricity is the build-up of electrons on such things as clothing and even on your own body. It is defined as an electrical charge at rest. Let's take an example. Here we have a non-conductive material. It could be our clothes or our skin. And while walking on a carpet, we could pick up a positive charge. Positive charge is then passed to our non-conductive material, so now making it more positive than it was before. If a further positive particle is absorbed by the material, more positive continues, then our material will ultimately contain a high degree of positive charge. Now let's take another further non-conductive material, such as some forms of plastic, and charge this, but this time with a negative charge. If these two charged materials come into contact, then one must discharge through the other. This is called electrostatic discharge. Once the static electricity has been discharged, then the non-conductive material will return to its original state. This charge can pass from person to person, in some cases causing a small tingling sensation. If this happens, then you have possibly just discharged at least 3000 volts of static electricity. If you can hear the discharge, then you can have released 6000 volts, and if you can see it, then it will be in excess of 8000 volts. Although these voltages are very high, they normally carry a very small current and under normal conditions will cause us no harm. However, some static sensitive devices such as CPUs, etc. can be destroyed by electrostatic discharge of only 30 volts. The three main ways of preventing ESD are grounding mats, wrist straps and packing. The first two are normally used with an earth bonding point or EBP. The earth bonding point or EBP plugs into the main socket. The live and neutral pins are made of plastic and the earth pin has a 1 megaohm resistor connected to it and the other end a fixing stud. Bench grounding mats are placed on the bench and normally consist of 3 layers. The top layer is a low resistance vinyl to dissipate the discharge, and the second being a conductive mesh, whilst the lower layer is normally a nitrocell sponge base to prevent the mat from skidding. It also has a fixing stud to allow it to be connected to an EBP. Floor grounding mats are similar to the construction of the bench mat. The Velostat mats have a much higher conductive surface and are more rigid than rubber mats. They can support heavier objects and have the ability to remove static discharge from items placed on them. Anti-static wrist straps are worn around the engineer's wrist, and the cord has either a fixing stud so it can be connected directly to an EBP or a crocodile clip which can be connected to the computer case. Anti-static wrist straps do not reduce or increase the risk of receiving an electric shock, and you should always follow the same precautions you would use without a wrist strap. Do not use them if you are likely to come in contact with more than 240 volts. Sensitive devices require protection from static discharge when in transit or storage. Such protection is achieved by enveloping the device in a material with a conducting layer. Often this packing material will also provide some mechanical protection. Anti-static packing bags are made from amine-free polyethylene and are cheap to produce. They can be found in either clear or pink and offer little or no protection from electrostatic discharge. Conductive bags are made from carbon-loaded polyethylene, black and puncture resistant. These give a moderate protection against ESD and are reusable. Metallized shielding bags consist of a polyester outer layer, aluminium center layer for shielding, and a polyethylene inner layer for static dissipation. This packing gives the greatest protection against ESD. The following are guidelines to prevent ESD. Do not work on a computer if you or the computer has just come in from the cold. Leave static sensitive components within their packing until ready to use. Avoid working on carpeted floors and use a grounding mat where necessary. Use wrist straps or grounding mats when available. Alternatively, touch the computer chassis to discharge yourself. Certain government legislation now requires that computers and their associated equipment, including monitors, printers, keyboards and mice, etc., are disposed of safely. Because of the harmful chemicals used to create them, it is no longer acceptable to use them in landfills. The Waste Electrical and Electronic Equipment, or WEEE directive, encourages businesses and organisations to recycle their unwanted computer equipment. These computer printers are collected by specialised companies who delete any sensitive data on them, clean and repair them. These items are then passed on or sold to the public, businesses and other organisations, which include schools, charities or even sent to developing countries. Any remaining equipment that cannot be recycled because they have reached the end of their useful life are broken down, and any harmful material that they contain is extracted and disposed of safely in specialised plants. WEEE is also seeking that the manufacturers of the components are directly responsible for the collection and disposal of electrical goods such as computers and monitors. When repairing, upgrading or servicing a computer, there will at some point be a faulty component that will need disposing of. This can now be accomplished by using the recycle facilities found at most domestic and business waste sites.